All right, 3 more units, something like that. Getting close. But today we're going to be talking about the area between curves. So it gets into some pretty cool information in my opinion. This is where I really started to like calculus because like, whoa, that's so cool. So this first one, right? It's just asking us determine the area of the region enclosed by the two functions. And that's all that we are going to be doing, is determining the area enclosed by the functions. There won't necessarily always be two, so I probably shouldn't have written that. But essentially what is happening, so if I take these graphs, 2x plus 5, it looks like a line, something like that, right? There is my f of x. For my g of x here, x plus 1 squared, that is a quadratic that hits the x-axis at -1. So I have something like that for g of x. And what it is asking me for here is the area enclosed by those two functions. So we are going to be able to find, being way too meticulous about this, the area enclosed between those two graphs. So really, it's not that big of a deal. It's not that difficult to do, but we need to kind of think about how these things interact with each other. So if f of x, right, if I do the area for f of x, it's going to take the sum of all of these heights right here and add them together. Right? If I do the sum of g of x, then it's going to take all of the sum of this area right here. So it's between the curves. So what I'm really looking for is the heights of f of x minus the heights of g of x. So what I can do is from the first part to the second part where they have their points of intersection is I can do the integral from a to b of f of x minus those heights of g of x dx, and that will give me just the part where they do not intersect, right? I'm taking out the intersection part. And that's it. That's really all that we're going to need to do on this stuff. So that's as much as we need to conceptualize. Now it's just going to be working through this problem. So in order to work through the problem, first I need to figure out what a and b are. So to figure out what a and b are, I can find their point of intersection. Right? And then I can solve this as I normally would. So x squared, let's see, minus 2x, so that's nothing. That would be minus 4. So interesting, x is just going from -2 to +2, so that's kind of nice. So I have it from -2 to +2 of, let's see, I need f of x minus g of x, so 2x plus 5 minus x plus 1 squared. So I'll go ahead and distribute all that. All right, and then I can integrate. Whoa. But I'm going to rearrange this stuff first. They are wild next door. All right, so I lose my 2x and my 2x, so I really have negative x squared plus 4 dx. So this is the integral. Well, I would just do negative x cubed over 3 plus 4x from -2 to +2. So let's see, if I do f of 2, it's 8/3. So -8/3 plus 8 minus a -2 would be +8/3. minus 8. So negative 16 thirds plus 16. And you can leave your area like that. Notice it is asking for the area, so I would say units squared on this one. So that could be the area. You can come. Oh my gosh, they are wild. You get common denominators if you wanted to and combine this stuff, 48, so that'd be positive 32 over 3 units squared is how you would see that on a free response question, or a multiple choice, I'm sorry. All right, and one thing to notice too is that with this stuff, a lot of the resources that you will see is what they will do is notice, like if I have kind of in a relationship, f of x is the function that I would call kind of the top function, or it had the higher y values. Over the interval, g of x was the bottom function. So a lot of places and a lot of resources that you will see is they will do the integral of a to b of the top function minus the bottom function and whatever your terms are, right? That will apply, and that's a rule that you can use to kind of help yourself with these things as well. Yeah, okay, let's do another one. All right, so we have x minus 1 cubed and just x minus 1. So I'm going to graph these, kind of help myself visualize. So x minus 1 cubed, does not look like that. It should look something like that, because I have a 0 at 1, have a y-intercept at negative 1. It's a cubic, so it starts at the bottom, ends to the top. And then I have x minus 1 as just a line that also goes through these two things. So I probably need a better graph. Yeah, let's pull up something a little bit better. If they are this close, we would probably give you what's going on here. Like you would be given a picture or something like that, saying that this is f of x, this is g of x, so on and so forth. Let's see, x minus 1 to the third, and x minus 1. Ooh. Okay, so cool thing here is that this area is going to be the same as this area. Because they are symmetric about this point x equals 1. So we could find the area from 1 to 2 and double it. That's one option. You could also just find both areas and add them together. Just remember this area is going to be negative. So, well, no, I think it's still going to come out positive. So I'm going to do the top minus the bottom, and then it'll do the minus the negative. So it'll take care of itself. So in my first one, notice my cubic is my top function, and in the second one, my line is my top function. So let's go ahead and set those up. All right, so I had from 0 to 1, my cubic was my top, so x minus 1 to the third minus x minus 1 dx, and then plus the integral from 1 to 2 of the line minus the cubic. All right, so that should give me the area. You could also, again, find one of them and double it, and that's the same thing. But let's go ahead and do both of them just for fun. So let's see, I have it from 0 to 1. This would be x to the third minus 2x squared. Nope, that would be a 3. 1, 3, 3, 1. And this would be just the opposite, so okay. So x cubed negative 3x squared plus 2x dx. And this one would be 1 to 2. Should be the opposite though, right? Negative x cubed plus 3x squared minus 2x. And yeah. All right, so if I do the antiderivative, then I have x to the 4th over 4 minus x cubed plus x squared from 0 to 1 plus that part, and then I have the next part, negative x to the 4th over 4 plus x cubed minus x squared from 1 to 2. All right. So if I put in 1, I have 1/4 minus 1 plus 1. So that would just be 1/4, and then minus 0. So then this part would also come out 1/4. So my area for all of this would be 2 times 1/4, which would just be 1/2. Again, that is because those things have that symmetry. All right. All right, in the next couple, what I'm going to do is I'm going to try to help you set them up. But by now we should be okay-ish with doing these basic antiderivatives and being able to plug in numbers, I would hope. If we're not, we need to go back and do some more practice, because that stuff is not going to be going away, especially as you guys are going into higher levels of calculus. Okay, so with this next one, notice I'm in terms of y, so it kind of changes how we graph this thing. Right, f of y is 3 minus y squared, so this is f of y right here. G of y is y plus 1, so g of y is right here. You can plug in numbers and verify that I have those graphs correct. You are more than welcome to. But essentially, right, we have a negative y squared, so I have a negative parabola. It's kind of like, I can't really show it that well through these screens, but it's kind of like if I were to graph it something-ish like this, but it's also kind of rotated. So just be careful as you're doing it. But we know with a y plus 1, if I put in y equals 0, right, then x has to be 1, right? When y is 0, x is 1. When y is negative 1, x is 0, so on and so forth. So kind of you're just putting in the y's and getting out the x's now. Okay, so the area here, I need to find my bounds, but I know it's going to be f of y minus g of y, because in terms of the higher function, the f of y has the greater, in this case, x values, right? So I'm looking at it from the side. Okay, so last thing you're going to do is just to find the bounds. So let's find the y values where they intersect. And notice I'm doing it in terms of y, I'm not doing it in terms of x. So when I find my intercept points, I'm going to write them in terms of y. So it should be going from negative 2 to positive 1. X, y equals negative 2, and y equals 1. And that would be it for that. Right, so then you could actually do the antiderivative, subtract those things, and it's exactly like you would do it in terms of x. Let's go ahead and run through it just to make sure. All right, so I have the integral from negative 2 to 1. And also, please note, as you guys go into BC, we really like to see these equal signs here, especially if you go across. If you go across and you don't write an equal sign, you write another integral from 2 to 1 of some junk, that's just turned into a bigger equation. However, if you write that, then we understand it's an equality. They're very picky about that as you go into the AP test. So just know that your math needs to be neat. It needs to be easy to follow. They don't like looking everywhere. They're also known that, like, if you have work all over the place, they will just not grade it sometimes. If it's too hard to follow, they won't even give you an opportunity. So your work needs to be neat. Okay. So f of y is 3 minus y squared minus g of y, which would be minus y minus 1 dy. So I have the integral from negative 2 to 1 of negative y squared minus y minus 2 plus 2 dy. So I have negative y cubed over 3 minus y squared over 2 plus 2y from negative 2 to 1, which means I have, so I put in 1 first, so negative 1/3 minus 1/2 plus 2 minus, put in negative 2, it's positive 8/3 minus 2 minus 4, and that would be enough for a free response answer. Really even less than this. You could just literally put in 1 minus when you put in negative 2, and that would work. But if we're on a multiple choice, we're going to need to simplify this a little bit more, so let's make sure that we can combine our fractions. Let's see, that's 2/6 and 3/6 will be negative 5 over 6 plus 2 minus 8/3. That would be negative 6, so plus 6. So this would be 8. And let's see, that will be 16 over 6, so minus 21 over 6, which would be 7 over 2. So let's turn 18 into divided by 2, so 16 over 2 minus 7 over 2 would be positive 9 over 2 units squared. And that would be my answer. Okay. So let's see, h of y is y, g of y is y squared minus 2. So if I graph this, y, pretty straightforward, is just that. So this is my h of y. G of y, y squared minus 2, would actually be a positive parabola with an x-intercept of negative 2. So I have something like that. So the region that they're talking about here is all in there. So my top function is h of y, my bottom function is g of y, and then I need to find my bounds. So I'm going to set up as h of y minus g of y dy, and let's find our bounds. So y equals y squared minus 2, solve it. So I have negative 1 and positive 2, so it's from negative 1 to positive 2. And then this integral would give me my area, right? So I'm not going to worry about solving that one because it's the same thing that we did in the last one. It's using your antiderivatives and the first fundamental theorem of calculus there. Okay, last one. I'm going to, can I copy this somehow? Paste. Cool. All right, I just don't like that bar, it annoys me. Okay, so with this one, I have a lot going on. There are a lot of functions, so let's see if we can draw this out. So y equals 8 is right here, y equals 3 is right here, y equals 0, y equals 3, and y equals 8. Then I also have g of y equals 0, right? So this is really just x equals 0. So I have my y-axis. Ooh, that's pretty bad. Okay. All right, so this is g of y equals 0 right here. And then I also have 12 over y, which will be a rational function. Something like that. So the area that they are talking about is the area right in here. So the nice thing is they actually give my bounds to me already, right? I'm going from 3 to 8, and it's really just of that function 12 over y dy. And that would be it. So this is just going to be 12 ln of y from 3 to 8. So this is 12 ln 8 minus 12 ln of 3, which I can factor out the 12. So this is just all not necessary, but I'm just rewriting it to remind you rules of natural logs and stuff. So 12 ln of 8/3 and then you could actually raise that to the 12th power if you wanted to. When ln 8/3 to the exponent of a 12 units squared. Right? And that's all there is to that one. So in the next unit, what we're going to start to do is be bringing in 3D objects, and we will rotate about axes. We will build out of nothing. So hopefully that will be pretty cool. I think it's pretty neat. But other than that, it's really just once you get how to set these up, it's not so bad in working through them. You just have to understand that you're doing the height of the top function minus the height of the bottom function, and that will give you the area between the functions. All right, as always, let me know what I can do to help, and I will talk to you all soon. Bye.